Okay, hello everyone, it's Salar and we are in part 47 of our tutorial, a tutorial to writing a real-time operating system. In previous part, I described the responsibility of kernel system call function, okay? And I said this function after calling user space system call call kernel system call, and this function put the arguments of this user space system call in system call list. But in this part I want to talk about SVC and system call, these parts, okay? In this part I want to talk about these stages in system call structure, and this will be a short part because this part is a easy part. But I said in this part I want to talk about SVC and kernel system call handler, okay? But kernel system call request, this function, you can see after calling user space system call kernel system call and kernel system call kernel system call request, okay? But what does this function do? This function first set a variable, set system call request in kernel control block. In kernel control block, system call handler request this member. First set this member, okay? But in future part you will realize why do we need to set this member, okay? First set this member to 1, okay, and return to kernel system call request, okay? After that, call SVC as I said in previous parts by using our SVC instruction, okay? So first kernel system call, after that in kernel system call put the arguments in system call list, and after that request for a system call by setting this member and calling SVC. And after calling SVC by using of this instruction, the RTOS enters to kernel space, and RTOS does all of its job in kernel space in SVC, okay? So but let's to see the SVC handler, okay? After calling SVC, after setting a member and after calling SVC, after setting this variable, this member, and calling SVC, now let's to inspect SVC handler of supervisor call. All of handlers in the RTOS developed in this file code interrupt handler.s. You know, the implementation of RTOS, as I said, you need PendSV, SVC, and systemtic. You need, and RTOS needs these exceptions. But at this time, I want to inspect SVC handler. Okay, but at the first time, you must push link register to the stack in addition of another register, because a stack must be 8-byte aligned. and you can't push just one 4-byte register. You need another register. For example, R0. This register is not important, but you must push link register to the stack in SVC Handler. After that, by using up this part of code, you must check the value of this request, this member, because this member shows you have a system call request. Okay, I said in future parts you will realize why do we need to check this member and why do we need to have this member. Okay, but before to talking about this part, let's just see this slide. As I said in previous part, in ARM assembly programming, according to ARM architecture procedure call standard, according to this standard from ARM, you need, this is an PDF file, this is a standard. When you have a function, for example, void function, and this function has an 4-byte integer variable. When you call this function, before jumping to this function, first compiler put this value, the argument, in register R0. Okay, you know, first argument will be sent by using of register R0. Okay, so 4-byte argument will be sent by register R0. When you want to call this function, when you call this function, before jumping to this function, compiler and the processor put this value in register R0. And when you have, for example, a function that its return value another time is a 4-byte integer. Okay, and assume you have no arguments. Okay, before returning from this function, when you for example, an integer number, okay, when the processor runs return line, before returning from this function, first processor put return in register R0, and after that return from this function. So after returning from this function, you have the return value in register R0 according ARM architecture procedure call standard. So let's go back to the handler of SVC. Branch and link to this function. But what is this function? Let's just see the definition and declaration of this function in kernel.c. You can see this function return value, system call handler request. Return this member, return the value of this member, and I said this member shows you have a system call request. Okay, so this function return the value of system call request in R0. Okay, after returning from this function, you have the return value of this function in R0, and if the request has been set, the value of request is 1, by using of this instruction, jump to this label, system call handler, jump to this label. and in this label call kernel system call handler. Call kernel system call handler. Okay, but let's debug the project and see this process. So here, let's debug this system call. When you have a system call, after checking interrupt and arguments, put arguments in a specific structure and put argument of a specific structure of arguments, this specific structure in addition of a system call number to a global structure, and call kernel system call. And in kernel system call, put the argument in system call list. And if atomic part is not broken, it's not been broken, break this part and call kernel system call request. In kernel system call request, first set this member. Now in kernel control block, this member has been set. Okay, system call handler has been set, and return from this function, and by using of port supervisor interrupt trigger, call SVC, immediately jump to SVC handler. First push register LR. After that, you can see the value of register 0 is 0. Okay. After running this function, you have the return value of this function in register R0. Now the value of register R0 is 1. This shows you have a system call request, and if R equal to 1 or has been set, jump to kernel system call handler. This function in kernel.c, kernel system call handler. Okay, so let's go back to the slides. So after, if you have a request in SVC, call kernel system call handler and enter to the kernel space. Okay, now let's inspect this function. This is a simple function. System call handler, kernel system call handler. I said kernel system call puts all of requests in system call list. So in the system call list, draw requests for system call. So kernel system call handler reads a request from system call list, and according to system call number I set in each global structure, you have a system call number. According to the system call number, jump to a kernel space system call. For example, at this time thread create new system call. Here is the body of kernel system call handler. First get a system call list and system call list index, and reads all of arguments in system call lists, and for each of them get the arguments and send this argument to kernel system call by number. Okay, and in kernel system call by number, from this argument get system call number, get this value, and according to this value jump to a kernel space system call. At this time thread create new system call. I said this is a kernel space system call, it's not a user space system call. Thread create new is a user space system call. Thread create new system call is a kernel space system call. Okay, so let's do debug the project and run this function. Okay, another time from first. If you have a system call, the user space system call collects all of its arguments in a specific structure. By using a specific structure and system call number, create a global structure and call kernel system call. In kernel system call, this function puts global arguments in a system call list, and if write is successful, call kernel system call request. Set kernel system call request member in kernel control block and call SVC. In SVC, first push link register. After that, if you have a request, its value is 1 another time. If you have a request for system call, in this if then block, jump to system call handler and run and call kernel system call handler. In kernel system call handler, read arguments in this list, and if you have a request, go to kernel system call by number, and according to system call number, at this time system call number is 1, system call number of thread create new, jump to kernel space system call. Okay, and here is kernel space system call, thread create new system call. Okay, so enough for today. I will talk about kernel system call, kernel space system call handler in the next part. Okay, now now you can understand what happens in process of system call from calling user space system call until here. Okay, and in the next part, at the for the last stage, I will talk about kernel space system call. At this time, thread create new system call. Okay, so after putting argument in system call list, set this variable and call SVC, and in SVC check if there is a system call request, call system call handler, okay, and in system call handler, by using of system call number, call a kernel space system call. Okay, enough for today, and the next part I will talk about kernel space system call. Thank you very much to see me, and see you soon in the next part.